Hi, I'm Scott Knockleby. In this video, we're going to look at the forward force solution for planar manipulators. So by the end of this video, you should be able to solve forward force problems for planar manipulators. So let's look at an example of the forward force solution for a planar manipulator. Here again, we have our planar 3R manipulator. And so for the forward force problem, we would know the torques being applied at the joints, tau 1, tau 2, and tau 3. And we want to find what is the wrench being applied by the end effector. So in this case, we're given our torques, which are tau 1, tau 2, and tau 3. All right, and we want to find our wrench F, which is Fx, Fy, and our moment Z. Okay, so we already solved the inverse force solution, and from that we found that our torques is equal to our Jacobian transpose times our wrench being applied by the manipulator, where our Jacobian transpose is just the same Jacobian from our velocity problems, all right, except just in the transpose form. So this is J transpose for our 3R planar manipulator. So if we want to find the inverse force, the forward force solution, we need to multiply both sides by J transpose inverse. So let's make a note. We're going to multiply both sides by J transpose inverse, which we can just write as J inverse transpose. All right, we're going to get J inverse transpose times tau equal to J inverse transpose times J transpose times F. Okay. This is simply our identity matrix. So we get F is equal to J inverse transpose tau. All right, and we'll call this equation star. So just like our inverse velocity problem, for the forward force solution, this equation is only valid if we can take the inverse of our Jacobian transpose, which is the same as being able to take the inverse of our Jacobian. So similar to the inverse velocity solution, a solution to the forward force problem only exists if an inverse to the Jacobian exists. So again, if the determinant of J is equal to 0, which is the same as the determinant of J transpose equal to 0, the manipulator is in a kinematic singularity and cannot apply an arbitrary load. All right, so our robot in a singular configuration couldn't apply arbitrary load in certain directions. The interesting thing about kinematic singularities for the forward force problem is it may still be able to sustain a load. All right, and we'll talk more about this when we look in further details about singular configurations of our robots.